Hi, I'm Scott Hunter, the Director of Product for Azure Developer Experience, and I'm here today to talk about how you can build amazing applications on Java with tools from Microsoft and with the Azure Cloud. We have a lot of stuff we're going to talk about today. We have some amazing demos, so please hang around and make sure you watch these demos. First off, we love Java at Microsoft. We are part of the Java community, and we are contributing back to Java, and I'm going to talk about each of these things today. We also use a ton of Java, and most importantly, we built some amazing tools for a Java developer, whether it's our own Java, Visual Studio Code, GitHub, and Azure. And we have some amazing other tools I'm going to talk about later today as well. Okay, so first off, as I said, I want to be part of the Java community. I don't just want to build a Java. I want to be part of Java. And so we are part of the JCP. That's the Java community process. This is the standards board that figures out what the language will look like and what will be in the VM. And Microsoft joined this last year so we can contribute more to Java. There's a variety of community engagements that we do. First off, there's Eclipse. We build amazing plugins for Eclipse to use it with our Java. We build an OpenJDK that anybody in Azure can use. It's fully supported. It's got a secure supply chain. We also are part of the Adoptium project. It's a vendor-neutral version of Java as well that we contribute to, and that's how we get Java 8 into Azure. Finally, Spring is a great framework for Java developers. We actually support that project, and we actually build a service in Azure to let you build Spring apps in Azure. And then, of course, I can't say enough about things like GitHub. GitHub has, tons and tons of repositories full of Java. We have support with Actions. We've got Visual Studio Code with a full ecosystem of plugins for debugging and testing and more. And of course, as I mentioned before, we're part of that JCP, which is how we actually contribute to the community. And then, of course, what I'm super excited about is we actually have our own build of the OpenJDK. So, if you're an Azure developer, we want to make sure you have the latest, most secure version of Java available to you day zero. And so this is a version of Java anybody can download. It's fully supported, and it's used through all of our Azure services. It supports both OpenJDK 11 and 17, and we do it across a variety of different operating systems, whether it's Linux, Alpine, Mac, Windows. We support tons of architectures like x86, x64, ARM64, and Apple M1 Silicon. We build both container images that you can download from the Azure Container Registry. We have tons of installers, no matter what your operating system is, whatever your package format is, we have you covered. Now, I mentioned a second ago about the Eclipse Adoptium, and that is a vendor-neutral version of Java, and it's led by the community, and we have contributed heavily into that project as well, and that's how, as I said before, we get Java 8 support into Azure, fully supported for you. This is one of the most exciting parts of what we've done. I said before, we contribute to the community, and we do some amazing stuff here. So if you look, we actually have built the version of the OpenJDK that runs on Windows ARM64. We've also put all the ports in to make sure that the OpenJDK runs on the Apple M1 chip. So whether you're using our version of Java that we ship, our contributions are in the public ecosystem. And so if you're running Java on a Mac or you're running on an ARM64 Windows device, those changes came from us. We also are a company that uses tons of Java, a lot of Java. For example, you're going to see here, LinkedIn, it actually has over 2,000 microservices written in Java. Azure both has services built on top of Java, and much of the infrastructure behind Azure is built on it as well. Minecraft, who can't think about Minecraft? Everybody knows what Minecraft is. Minecraft is built on our version of Java. If you use Bing, which is a search engine that goes and powers the internet, much of it is actually using big data on Java to actually search and hold the index of the entire internet. And of course, inside of Microsoft ourselves, we have over 2 million JVMs in production. That does not count customer code. That's just our code inside of Microsoft. So we are a big, huge user of Java. And if you download the Java edition of Minecraft, that runs on our version of Java, the OpenJDK that we build. It powers millions and millions of players every single day. And of course, you can see as we migrated Minecraft from an older Java to our new Java, you can see customers saw the performance improvements that we've made in Java during that time frame. And then, of course, we're Microsoft. I work in a group called Developer Division. We build developer tools and frameworks And of course, we need to make sure that our Java developers have amazing tools. You can see here we have Playwright. Playwright is a framework for testing front-end web applications, and it fully supports Java. We have GitHub Copilot. What it will do is it will actually give you code suggestions and code fixes on the fly as you type, and it fully supports Java. We also know that many developers today are actually building applications that are going to run on Linux. And so if you're building on Windows, we have the Windows subsystem for Linux, where you can actually have a full implementation of Linux, not an emulation, but a real Linux on Windows. And of course, that supports Java. And then we have Visual Studio Code. It's our very popular lightweight editor with lots of great plugins for Java. And then, of course, GitHub, which I mentioned earlier, it has support for actions to do CI/CD for your Java applications. So you can see here, all of these amazing tools work great with Java as a developer. Visual Studio Code, 1.5 million active Java developers today using this. And I have to thank my partners like Red Hat, who helped build the amazing plugins for Java for Visual Studio Code. Azure has tons of great support for Java developers. Number one, we have our OpenJDK, fully supported across all of our services. You can see here we have Java 8, Java 11, Java 17. I mentioned earlier the Spring framework. We contribute to that. We have a service for that. And then, of course, we support all the open standards like Jakarta EE and so on. When I think of Azure, we have lots of places for you to run your Java code. All the way from the far left, if you want the most control you can get, you can build a VM where you contain and can control the entire image for your Java application. Maybe you want to run on Kubernetes. It's an up-and-coming, very popular, it's vendor-neutral, cloud-neutral. We have Azure Kubernetes Service, great support for Java. And then you scroll a little bit more to the right, and you can see we have something called Azure Container Apps. This is something we just launched at Build this week. Container Apps is really cool because it lets you run your Java apps in containers on Kubernetes, but you don't have to manage Kubernetes at all. And then if you want platform as a service, you can see that Azure Web Apps has great support for all of our popular app engines for Java. And then on the far right, if you're a Spring developer, we have a service just for hosting Spring applications in Azure. So you can see full control to the left, all the way to full PaaS with Spring Cloud. We have tons of great options for you to build awesome code on Java with Azure. And with that, I'm going to turn it over to Bruno and Rory, and they're going to do some amazing demos showing you what you can build with Java.
Hey, Scott, thanks for having us.
I'm very excited to be here, Scott.
Well, Rory, we are all excited because when it comes to Java development in the cloud, what Scott said just before, like code, deploy, and scale, I mean, developers want to code with the tools that make them productive, tools that make them excited about software development. And then when it comes to deployment, they want to make sure that those applications can be deployed, especially in the cloud, with the best tools that are available to do that. And finally, scaling. Once the application is in the cloud, how can developers really manage those applications for the scalability that those applications may need? So when we think about these three pillars, when you start with coding, it's about choosing the tools that make developers productive, tools that they love, tools that they are used to. And Microsoft has great integration with existing tools like IntelliJ and Eclipse, but we also work with some tools that developers are becoming more and more familiar with, like Visual Studio Code. And now with Microsoft to build OpenJDK integrated with some other tools that make part of the Microsoft tool set for software development, like Playwright or Windows Subsystem for Linux, so Java developers can be closer to a Linux-like environment that they are most familiar with in production. So developers combine these tools to create great application. And once they have those applications ready to be deployed, they combine things like GitHub Actions or Azure DevOps, and they use those things through build tools like Maven or Gradle. And with Azure CLI, they can easily combine the flow of their CI/CD environments to push things and artifacts to a repository that can then be used for actual deployment in an Azure service or in a cloud service. And when the scaling part comes in, it's about choosing the right service for the needs of applications. So if it's serverless, Azure Functions. If it's containers or Kubernetes, there are plenty of options. And today, Rory will come back here and talk to us about using Visual Studio Code, Microsoft Bit of OpenJDK, Playwright, GitHub code spaces, and Azure Container Apps. So Rory, it's on you now. Thanks.
Thanks, Bruno. So we're going to start with taking a well-known application, the Spring Pet Clinic. So I've got this application and I've cloned it locally to my desktop. So it's got a source folder, a target folder, and your Maven build project. I've installed the Microsoft build of OpenJDK, and I've also installed the Visual Studio Code Java extensions that you can actually get in the Visual Studio Code marketplace. So the first thing I want to show you is that I'm going to run this project, and we're going to see what is the Pet Clinic. So I can go into my run, or I can actually go into Java projects, and I can just click on the top of the Pet Clinic application and click in run. And this is going to start a local instance of my application, and it's going to bind it to port 8080. Once that's done, I'm going to show you a little bit of a trick, because I'm going to go in to my browser, and you can actually go into command palette, and you can go simple browser and http:// localhost port 8080, and there's my Pet Clinic application. So the Pet Clinic application takes an owner. So let's go find an owner. So we're going to find the owners, like George Franklin. And George Franklin has pets. So we've got Leo. And you can add a visit to that pet to a veterinary. So Leo's a cat, and we can say that vet visit. And we can add Leo to go visit the vet. So pretty simple, very popular application. Next, I want to show you how to do local code debugging using Visual Studio Code. So in my application, I've got my source folder, and I'm going to put a breakpoint where we have the owner controller. So I'm going to go into source, owners, and in the owner controller there, I want to check, wait a second, is someone searching for an owner that has no last name? So let's go back down to the find command there, and I've got a system out there, so system out print owner.get last name. I want to put a debug breakpoint there. Now I'm going to go back into my simple browser, and I'm going to go in and try find an owner again, but don't put a last name in there. So find an owner there, and it's going to break on owner.get last name. I can go into my watch of my breakpoint there, and I can see that the last name is empty. But I also want to be able to do live code changes without debugging. So I'm going to take that breakpoint off and carry on, resume. Next, I'm going to go in and I'm going to put in a change. I want to get a better error message out of my console. So without stopping my server, you can see my server is still available. I'm going to go name, and I'm going to go the owner for the name there. Now, all I'm going to do is hit hot code replace, go back into my simple browser. I watch the bottom there, and I'm going to go find that owner there. And now I can do hot code replace, and also along with my debugging. So I want to show you now how to do integration tests. So if I go into my source control here, and I go into my test folder, so let's just stop that server. If I go into my test folder here, you'll see there that under tests, I have a Playwright test. Now, Bruno mentioned that this is a very powerful tool. Now, this is starts up a local version of my Spring Boot server. It's going to test create owner. It's going to find the owners, go to the find owner screen, add an owner, first name, last name, address, city, and telephone. Click on the add owner button, and then test whether the owner is equal to Rory Pretty, my name. But you'll see there, the name is spelled incorrectly. It's with an I and not with a Y. We're going to go to the Test Explorer view. We're going to run that, and we're going to expect this to fail. Now, this is an integration test. We already saw how to do debugging. This is going to bring up our own version of the server. You can see here's the server here. It's going to run the test in Playwright, bring up Chromium, and then it's going to go into the screen, the HTML, put in those fields there, and then test whether we actually stored Rory Pretty. And you can see there it worked, but it didn't work like we wanted to. So we want to make sure that our test does pass with a Rory with a Y, run that test again, and now we should get a passing test. So it's very powerful Visual Studio Code to be able to do your local debugging, your unit testing, and also your integration tests using Playwright. Next, I want to show you how to actually take what we just did here and push it into Azure Container Apps. I'm going to give you a brief introduction to Azure Container Apps before we get started. So over here is my Azure portal, and I've set up a container app called Spring Pet Clinic, and that container app there really is running Kubernetes underneath there, and it's going to take our application as a container and use that container to run a revision. So what is a revision? It basically is a snapshot of your application. So that's the registry we're going to use there, and we're going to create a Pet Clinic image using Docker, and then we're going to run this on our Pet Clinic application. So if I go into here, it actually gives me a URL of my application, and you'll notice the first time I ever hit that URL, it actually takes a few seconds to start up. Now, this is one of the powers of container apps because it actually has 0 instances hot deployed for you. And that lowers the cost. Now, you can actually set that. We're going to see the example a little bit later, that you can set that with a scaled out image. You can see there's the application. And as soon as I stop it, it's going to go back to 0 instances ready. And we're going to see how we can change that and also do some CI/CD using GitHub Actions. So next, I'm going to go into my repository, into my application here. And now I'm going to go into my actions. And I'm going to show you the previous build that we ran there. You can see that there's my previous build. And it did a build, which was build the Docker file and push it to a container registry. Then it did a deploy into our application to our container app. Let's go do some changes to this and see this run in real time. And to do that, I'm actually going to go in and open up GitHub code spaces to do that change. So you can see there, I've got the create code spaces on that branch, and I've already got that running locally here. So I've got my GitHub code spaces here, and this is the Docker file in my repo. And you can see there, I've got the base Docker image there, which is the JDK 11 of the Microsoft build of OpenJDK. I'm exposing that port 8080. I'm taking my jar file, and then I'm executing that. But I also want to increase the max RAM percentage to allow my Docker container to take full advantage of that memory allocated. So I've got that entry point there. I'm going to delete that there. Now I'm going to build my application locally in my CodeSpaces environment. And then I'm going to run that application, and I'm going to bind it to port 8080. You can see there, it immediately picks up that you're wanting to use port 8080. Let's wait for the application to start up there. And then you can actually go and open in your browser and debug in GitHub CodeSpaces your Docker containers. You can go open in browser. And this is the port 8080 that Docker is hosting. So I find my owners, and there's my Docker container. So let's stop that, and let's actually go in and commit that file. So Control-C, I'm stopping my Docker container. Now I'm going to push this. So if I go into source control, and I hit refresh here, let's just go entry points, and we're going to go there, hashtag new change. Let's save that. There we go, the Docker file. And I'm going to add that file to the change. And I'm going to push that change there. So I'm going to commit it. New change. That. And then I'm going to push that change there. Push. Now, the minute I push that, it's actually going to trigger a GitHub Actions build. So I can go into my repo now, my samples, and on my action, you see there that it's triggering a new change, and that change has got the build and deploy that we already covered on. Now let's look at exactly what's going to happen with the scaling. So when we go back to our container app, so we've got our container app. I did promise you I'm going to show you scaling. So on our containers here, so you will see there under containers, there's two little options that you can specify in containers. So you can specify the number of cores and the memory size for resource allocation, but you can also specify scale. Now scale, we've set it here to 0 to 5 instances. You can see there, it's max replicas 0 to 5. So while that build is running, you'll see there that by default, it doesn't have an instance running, and it's going to save you on costs. We also have a scale rule. So if we click on that scale rule there, we'll see that the scale rule is set that if there's 100 concurrent requests on HTTP, then it's going to scale up an additional instances based on those requests, allowing you to start off with 0 and to scale up according to your load. Remember, this is Kubernetes, it's AKS and underneath there, and it's really powerful. It gives you all tight integration to Azure services. So let's go back into our build there, and let's see exactly what we're going to do. And finally, let's hit our application and make sure it's running. So our build application is busy running here. It's setting up the job. It's setting up the Microsoft build of OpenJDK. It's pulling the image and pushing it to the container registry. That is an Azure Containers registry. And once that's completed, it's then going to deploy that to our build. You can see that that is pretty quick. We've got Maven. Now, I'm a big fan of Gradle, so you can use Gradle also. It's building with Maven. It's logging into the containers registry, and it's completed the build section. So let's go back to our action there. And now we're going to look at the deploy section. Now, the deploy section is going to use the Azure CLI to do the deployment. You can actually look at the file if you go to workflow file. So if you go into the deploy section here. So the deploy section, as we're doing the deploy, you see there that the deploy section there, we're going to do an AZ container app registry set. It's going to set the registry that we're going to get the file from. It's going to do an AZ container update. And it's going to go and push the container app with the image file that we specified in our container registry. And all of this is available via the Azure CLI documentation and also this example repo. So let's see here. So it's deploying to the container app there. And we should see, once it's completed, the revision get an update. So if you want to see if the revision gets an update, you can actually go to Revision Management under Application, and you can see that the date created is going to be the date that we push that revision. Let's go back to our build, and let's wait for that to complete. Deploy to container app. It's updating the existing registry. Now, you can run multiple revisions. So right now, we have one revision, and we're overwriting it every single time. But you can have multiple revisions, and you can mark each one active or inactive. And coming up very soon is labels. And labels allows you to use staging or production to really set the stage for blue-green deployment, canary deployment, and so much more other powerful features of container apps. So let's go in and see that's completed now. Now we can actually go into our application, our Pet Clinic application, and we can hit that URL, and we're confident that we have the new revision pushed there for our application. And voila. And it scales from 0 to 5 based on HTTP. I'm going to bring back Bruno onto the screen, and we're going to just round up there with the end of there.
This is such a powerful demo, Rory. And while we were working on this, we realized how the pieces are coming together and integrating very nicely. You know, VS Code, integration with JUnit, Spring Boot, part of that story as well. And then we have the Azure CLI with the container registry, easy to build. I remember that you showed me like this command that developers can use on the Azure CLI that will actually generate the YAML file that sets all this integration with GitHub Actions. And,
that was our secret. Yeah, Bruno, that was our secret. But you can actually use the Azure CLI to go in and create your GitHub Actions, which is very powerful. So everything is there for you. And to start to finish, it's such a really easy experience to use Visual Studio Code, the Microsoft build of OpenJDK, to use Playwright, to push to a Docker container, use Azure code spaces, and then to push to container apps using the GitHub Action. And it's just start to finish a very succinct and easy developer experience.
Excellent, excellent. Rory, thank you so much for this amazing demo. Everybody watching, go visit the URL of the repo so you can learn more about the configurations. And thank you so much, Rory, again. Scott Hunter, back to you. Thank you.
Cheers, everyone.
Thank you, Bruno and Roy, for those amazing demos. You know, I'm so excited, and I think developers will be excited to try those features and those services. Just a quick recap. We love Java at Microsoft. We want to be part of the community. We're contributing back, and we're building amazing tools for you, the Java developer. We want to contribute more, and you know, we use a lot of Java, but most importantly, as a developer, we build some amazing tools, frameworks, and services for you, the Java developer. Please check them all out. If you want to learn more about this, there's the Microsoft Documentation Hub for Java. You can check out this URL and learn more about what you can do in Azure with Java at Microsoft. And then finally, you know, we love talking to our customers. Find us on Twitter and ask us whatever questions you have, whatever features you want. We're happy to respond. And we have a blog on what we do for Java at Microsoft. Please check it out. Have a great build.